Hi, welcome to the Children's Science Center. My name is John, and I'm super excited to be able to read this book to you today. It's called What is a Scientist by Barbara Lehn, photographs by Carol Krauss. Let's go ahead and get started, all right? What is a scientist? Let's find out. A scientist is a person who asks questions and tries different ways to answer them. Hannah wonders about fruits and vegetables. Are there this many peas in every pea pod? Asks Hannah. How many peas do you think are in a pod? I think there's 7. A scientist learns from her senses. Cammy and Tiara play with a mixture of water and cornstarch. They try to decide if it's a liquid or a solid. When I squeeze it, it feels like a solid, but it drips like a liquid, observes Tiara. That's interesting. I wonder what it is. A scientist notices details. Nate examines the inside of a vegetable. There are actually 2 kinds of seeds inside the cucumber. The small ones are clear, discovers Nate. I wonder how many seeds are in, say, an apple. A scientist draws what she sees. Samantha shows how 2 liquids mix. The red drops beaded inside the yellow liquid, observes Samantha. That sounds a little bit like oil and water. A scientist writes about what happens. Tim records his observations. The pencil in the checker landed at the same time, but not the feather, writes Tim. I wonder what caused that. Can you guys think of anything that might have changed what happened there? A scientist makes comparisons by measuring. Amelia and Corey are measuring weights with the balance scale. Amelia, this side of the balance is higher because it is lighter, demonstrates Corey. It looks like Corey's measuring how tall it is. Maybe he's using something like a ruler. You guys ever use a ruler to measure anything? A scientist must count exactly. Emily and Stuart count how many drops of water they can fit on a penny. We've put exactly 23 drops of water so far, says Emily. I wonder how many you can fit on a penny. Maybe that's an experiment we could try. A scientist looks at objects carefully and decides how to sort them. Zoe and her group organize the shoes and boots in different ways. You guys, I think this boot is longer, decides Zoe. Have you guys ever tried to sort your toys? Usually I sort my toys by color. So I got red, orange, purple, you know. A scientist designs experiments to test predictions. Jessie plants seeds at the top of one cup and at the bottom of another. I think the seeds at the top of the will grow better than the seeds at the bottom, predicts Jessie. I think the ones at the bottom, but I have to go test it, so maybe I'll go do that later. A scientist experiments by trial and error. Nick uses a foam meat tray to make a flying object. I added a blob of clay and some paper clips on the front, and now the meat tray flies further, explains Nick. I wonder if it has to do with the weight. Scientist thinks logically. Shivani explains how she learned about the compass directions. When I ride home at the end of the day, the sun is going down over there, so that must be the west, figures Shivani. That's actually interesting. The sun rises in the east and sets in the west. The scientist keeps trying over and over. Charlie and Stuart are trying to build a tower as tall as possible. Stuart, we finally got more than 10 pieces to stay on, shouts Charlie. Ooh. You know, towers are my favorite thing to build. And finally, a scientist has fun. Jeff and Teresa experiment with water. Let's see if we can fill up the tube through these holes, suggests Jeff. That looks like a pretty big tube. Wonder if they can do it. A scientist is a person who asks questions, learns from their senses, notices detail, draws, writes, measures, counts, sorts, tests predictions, experiments, thinks logically, keeps trying, and has fun. That's what a scientist is. And that's the end of the book. Thank you all for coming to watch me, and I hope you guys really like this book as much as I did. Bye!
Hello, scientist Ashlyn here to do a science experiment with you all. But wait, what is a scientist? And what is a science experiment? Did you all know? I'm talking to all you, that you are scientists too. It's true. Every time you try something new, you're a scientist. So picture when you're a baby and you put your shoe in your mouth, yum, yum, yum. Wait, did you all do that? Okay, maybe just me. But you were testing it out. You were seeing, does my shoe taste delicious? Or maybe you threw your Cheerios, or maybe you ran around, or blew bubbles, right? Anything you try out for the very first time is doing an experiment. So when we do an experiment, we ask a question and we try and figure out the answer. So today, I'm going to be asking a few questions, and I want you all to pay attention and see if you know the answer. So I have all of my materials right here, except I think I'm missing something. I know I have something else somewhere here. Let me see. All right, a hammer. I don't know if I need that. Gloves? What would I need gloves for? All right, let me see. Woo! All right, what else do I have here? Oh, it's getting cold. All right, let me see. I have something in here that I'm going to be using today. Oh, let's see. I have a big piece of it. So this is a piece of ice. But this ice is a little funky. It's a little different than normally when we hold ice, right? Normally if you hold an ice cube in your hand, it is melting. And that solid, hard ice will turn into water. Has anyone ever done that before? Held an ice cube in their hand and noticed it turning into water? This one's doing something different though. It's not turning into water, but it's turning into a smoke or gas. Do you all see that water vapor coming off of it? That steam. So instead of going from a solid, ice, to a liquid, like water, this is going straight to a gas. And we have a very special word for that called sublimation. So it is sublimating right now. Sublimating, sublimating, sublimating. Well, okay, that's kind of cool, right? But what is this stuff? And how is it doing that? All right, everybody take a deep breath in. We just breathed in oxygen. It's the air all around us that's invisible. Can you see the air? Not really. Sometimes you can hear it, and sometimes you can feel it when there's a big gust of wind, right? So that is oxygen. Oh, let's take a deep breath in again. And deep breath out. That air that we're blowing out is carbon dioxide. And that's another gas that's in the air all around us and is normally invisible. But now we can see it. This is actually frozen carbon dioxide. They took all that gas, all that air around us, that carbon dioxide, and smushed it together where it was really, really cold, over -100 degrees Fahrenheit, to get that gas to freeze. So this is what we call dry ice. We call it dry because it's not wet, right? And it's kind of like an ice, but it's really frozen carbon dioxide. Now, I want to see what happens if I put this carbon dioxide in water. Wait, that's not fitting. Let me see if I have a smaller piece. Let's see what happens when I get some smaller pieces in there. And you can see I'm making a little bit of a mess. That's another thing scientists do. We get pretty messy. All right, is anything happening? Let's see. Oh my goodness! There's even more of that steam or gas that we can see. And you see how it's bubbling? When the carbon dioxide hits the water, it reacts with it and creates carbonic acid and transforms into a gas. Since gas is lighter than air, think of a balloon up, up, up in the air. Gas is lighter than the water. It wants to escape. You can see the bubbles coming out of there. So it escapes out the top into this steam. I think this is pretty cool. I want to grab some of it. Wait. Okay, here, let me go like this. Oh, it's coming out that end now. How do you think I can grab some of it? Let's see, let me put it all in my hands and let me bring it towards you. Oh, wait. There's not any there. All right, I'm gonna see if I can find a way to trap this gas. Does anyone have a guess on how we can do that? In science, we make guesses all of the time, and we call that a hypothesis. Now, it's not a hippopotamus, but a hypothesis. So I have a hypothesis that we can trap this gas, at least for a little bit. My hypothesis is that we can't trap it for very long, but we can maybe trap it for a little bit of time. So let's try it out. So let's see, what other ingredients do I have here? I have some soap in this bowl, some of this blue dish soap, and I'll put a little more in there just to make it extra fun. And I also have some glycerin. Glycerin's kind of like a really thick, extra sticky soap. It can be used in soap, shampoos, things like that. So I've got all this stuff in here. And let's see, let me pour a little bit of it in here. See if I can get soap to trap the gas. Oh my goodness! What is happening? Do you all see that? What is it forming? Well, it's forming what normally happens when we mix soap and water. It's forming bubbles, right? But look at these bubbles. What do you think would happen if I popped one of the bubbles? Should I try it out? Because that's what other things scientists do, is they try things out, right? They experiment. We're gonna ask a question, what happens when I pop these bubbles? And then we're gonna try it out. So let's see, ready? Bloop. Bloop. That might be a little hard to see, but when I pop the bubbles, the steam, the gas escapes. So I can trap them for a little bit, but not very long, right? Let's see if I can get even bigger bubbles, because these are just little tiny bubbles, right? So I have this fancy contraption here. This is a thermos, so it's keeping the water warm on the inside. Now, warm water will make the carbon dioxide go off even faster because it's making it warm up faster or turn into a gas or sublime faster. So let me get this cap off. I've got this weird tube attached here, but this is gonna be my bubble maker. This will make it really, really fun. So let's see. All right, we've got some warm water in there. And does anyone have a hypothesis or a guess as to what's gonna happen when I put the dry ice in here? Take a moment to think. What's gonna happen? Is it gonna explode? Is it gonna turn to ice? Is it gonna turn to gas? Let's see. All right, I'm gonna put one big piece in there. And oh my goodness, how about one more? It's really going. It might be hard to hear, but let's see if we can listen and hear the bubbling. I'm a mad scientist. No, just kidding. I'm a happy scientist. But this looks like a witch's potion, doesn't it? But it's just science. This is my favorite part about science, is how fun and cool it can be. Get it? Because the ice cubes are really cold. All right, okay, so I've got this gas. It's going all over. If I wave my arms around, it'll go all over the place. Ooh, but let me see if I can kind of concentrate it and put it in one place all together. So let's see, I'm gonna get this cap on. And as soon as I get the cap on, what's happening out of this tube? All the gas is going in one direction, right? I concentrated it. Because I tied this a little tight here. Let me unscrew this. And let me lift up the top of it. Whoa, it's still going. Oh, and there's still some in here too. Let's see if I can get that all out. Okay, so we've got a little extra stuff going on in here. Let me try this again. All right, so I closed it a little bit tighter. There's still a little bit leaking on here, but let's see what happens when I get, oopsies, spilled some bubbles, if I get this in my bubble mixture. What is happening? Oh my goodness, it's making gigantic bubbles. Do you see those big bubbles? So the soap is forming around the gas and it's holding it together. Not for too long though. You can see there's enough pressure. The gas is trying to escape. And so when it hits the ground, it'll drop. Let's see if I can get any bubbles to not pop. I'm putting soap on my hands so that they feel the same. Let's see, you need some more soap in here. Let's see how many bubbles I can get. Ready? Oh, there's one. There's one really, really big bubble. Oh, so close to two. Okay, let's see if I can get two. Ready? Two. Oh, and I popped both of them. But do you see how the gas escaped when it popped? Oh, I have this really big one. Let me see if I can get this one closer. to the camera so you can see this giant bubble. And I call this boo bubbles because when you pop them, this smoke comes out and it looks like Halloween. Let's do a few more. Let's see, now that I've got it working, let's see how many bubbles I can make. Oh wait, yeah, there's not enough of this coming out. Let's see if I tighten this, if that'll work a little bit better. All right, bloop, bloop, bloop. Oh, now it's a little too tight. Oh, there we go. Oh, I've got another bubble. That's one. Oh, that's two. Oh, and when they two come together, they kind of popped. I like how they're bouncing off of each other though. I think that looks really cool, right? So what we did is we used soap and water to trap a gas. And this actually happens in a bathtub or when you rub your hands together when you're washing your hands. Let's see if I can put this in there. Oh, that was too much smoke. So this is using a few different kinds of science. We're using the chemical properties of soap that want to make it stay together. We're learning about the states of matter, solids, liquids, and gases. And we're having fun while doing it, right? And that's what a scientist does. They learn, try things out. If it doesn't work, they try it again. And they keep learning and exploring the world. All right, that's about all I have for you guys today. I hope that you enjoyed learning about my magic boo bubbles.